Welcome back. Ever you wondered what keeps your favorite apps running smoothly even when something goes wrong? The secret lies in redundancy, a core concept in system design that ensure reliability and availability. And it's one of the more important things when it comes to system design interviews. So, let's try to answer this question as always of what is exactly redundancy. Redundancy in system design means having duplicate components, so if one fails, another takes over. It's a strategy used to enhance reliability, ensure high availability, and minimize downtime. Let's try to answer the other question, why it is important. In a world where downtime costs companies millions of dollars, redundancy isn't just a luxury, it's a necessity. From preventing data loss to keeping critical systems online, redundancy ensures uninterrupted service. There is multiple types of redundancy. There is a hardware redundancy, network redundancy, data redundancy, and geographical redundancy. And we will talk about each one of them in the next videos. Okay, we have this system. Right now we need to assume that we have like some sort of real world example. We have a system that we need to add to it a redundancy. Let's focus here on our load balancer. We only have one load balancer server. If this server goes down, our client cannot send requests to our web servers anymore. So this application is a single point of failure. And this is how you implement the redundancy. First, you identify the critical components in your systems, and these are the single point of failure. After that, we need to introduce backup or failover mechanism for those components. So we can add a secondary, oh no, let's delete this. We can add a secondary load balancer that will be on standby. Whenever our load balancer fails, this new load balancer, let's call it new balancer 2, will take place. So it will continue to distribute all the incoming requests and will make sure that our system and our service is not interrupted. So you have 4 steps in order to implement a redundancy. First, you identify the critical components in your system. These are your single point of failure. Second, introduce backups or failover mechanisms for those components. After that, you will could use like a failover mechanisms to switch over. So you will use the next load balancer. And lastly, it's important to do regular tests and monitor your redundant systems to make sure they work as intended. So this is how it works. Redundancy also has a pretty important things because there are some real world examples use redundancy in action, like Netflix uses geographically redundant servers to ensure uninterrupted streaming, and we will talk in the future what is a redundant service. Payment system uses redundant payment gateways to prevent transactions failure during high traffic. Cloud providers like AWS or Google Cloud offer multi-region redundancy to keep your application running smoothly. Okay, it looks redundancy is a great thing, but does redundancy has some sort of like trade-offs? What are the trade-offs of the redundancy? While redundancy is essential, it comes with trade-offs. Adding redundant systems increases cost and complexity because we're adding more systems to take over if the main system or the main server or the main system has any problem. The key is to find the right balance, like focus on critical components where downtime or failure is unacceptable. Okay, the second question we need to answer is, when redundancy is non-negotiable. There are multiple systems or industries that redundancy is not an option, but we will focus on 3 things here. First, hospitals require redundant, powerful systems to keep life-saving equipment operational. For any healthcare system, redundant is non-negotiable. Financial institutions ensure transactions integrity with redundant databases. So, in any fintech-based application, redundancy is pretty important. Airlines rely on redundant navigation and communication systems to ensure passenger safety. Also, it's non-negotiable. Okay, let's go to our conclusion. To wrap it up, redundancy is your safety net in system design. There are multiple best practices you need to follow. Identify critical components and potential single point of failure. Use a mix of hardware, network, and data redundancy. Regularly test failover mechanisms to ensure reliability. Optimize costs by focusing on the most critical part of your system. Remember, redundancy isn't about eliminating failures, it's about being prepared for them. So, that's it. If you found this video helpful, don't forget to like it, subscribe, and hit the notification bell so you'll never miss any video, and see you in future problems.